I thought I would do something slightly different today. So, here I'm going to discuss my experiences of my experiments that I've been doing really with home network setup, and in particular virtualization technology with Linux, and in particular IOMMU and PCI-e pass-through. So I've just got a few things that I've made some notes on paper, which I'll just briefly discuss. My apologies if you can't read these. They're not particularly clear on the screen at the moment. My camera on my phone is not particularly good, and the light isn't particularly good in here at the moment because it's the evening. But I'll try and make it as clear as possible. So I just wanted to discuss first off some of the objectives or physical constraints that I have. So when I was at university, I had my own place and I could do essentially anything I wanted. I could have wires, LAN cables, network cables, essentially anywhere as long as I didn't drill through the walls of the flat that I was renting. And that meant I could have a very flexible setup. Now I'm back home, I can't really do that, and I have to work with really what's available. And so the way my house is set up here when I'm back home is that there are, broadly speaking, 3 rooms. There's a room where my ISP router is, and that has to be there because that's where the coaxial cable comes in. And then of course there's a standard cheap ISP router, no brand names mentioned here, ISP router, which just has the address 192.168.0.x, so that's on the first network, if you like. This particular ISP router doesn't support static routes, static routes if you prefer. One way around that could be to use a DMZ, a demilitarized zone. I've not really tested that. I think that could be a possible solution, but the hardware generally is poor quality and it's unreliable. It needs restarting every few days or weeks, really. So I prefer to just keep that AP as just an internet-only access point, and basically to administrate and control everything else further upstream, which is entirely within my control. So then following on from this, there's my room here, which I've labeled as room 2. This is where the networks 192.168.2 will be, and any others that I wish to play around with. So the .2 is just for my own systems. I was doing some things a while ago with some big data processing. It was a project that went on for several months, and so I had a lot of bandwidth, a lot of traffic around this network. So one of the reasons to segment it away from everything else was just purely not to clog up the network for everybody else. So the 192.168.1 network then is what I call the internal public services network. So that contains traffic really for everybody else that I live with. It contains services such as NAS storage that I have deployed, and also things for printers, that kind of thing. And then, just to summarize, there's other rooms, which basically means every other room in the house, and the only network that's available there is the .1 network. So if you're on the .1 network, you can access features such as the printer or the NAS services, storage services, things like that. But you can't access any of my private or experimental stuff that I have, which is on the .2 network. And then in future, I plan to add something that is genuinely a public network with public accessible services, which will be on some other network, which will be segmented as well for security reasons. So that's just an overview of how my network looks like here. And one of the main constraints I have is that to my room there are 2 gigabit connections, two Ethernet wires. They run at gigabit speed, and there's no way really to put a third one in, or at least there's no convenient way to do that without causing a fair amount of disruption. And you'll see why that's important on the next slide, or sheet of paper as it is. So I looked to implementing a solution with virtualization and IOMMU, and I did some research before I bought any of the components I bought, thinking that my research would be good enough to understand everything and for it to work as I expected, and it turned out that wasn't the case. So this is really to just make you aware of some of the limitations of IOMMU, even on prosumer hardware. So this is a diagram of the server system that's running in that first room that was on this previous sheet of paper. So in this room here, where the ISP router is, there's a piece of hardware here which functions as many things. One of the things it does is it's the router which connects the .0 network to everything else. It has a few things on. It's got a management Ethernet port, which isn't useful for routing, sending any traffic. It's just for management purposes. There are two on the motherboard connections for gigabit Ethernet as well. I don't tend to use those too much. One of them is just to have a network connection to this system generally, and the VMs that don't have any network cards passed through. So this is an ASUS P10SM board. I bought this one particularly because it has a fairly large array of PCIe connections. In particular, it has 3 8x physical connections, which is very handy for things like host bus adapters, which generally are all 8 width for, as in physical 8 width PCI standard. They're also generally 8 times link, which we don't have because of the limitations of this class of hardware. This is a 1151 socket system. There's also a times 16 slot, which is not especially useful to me, but it's useful again as another 8x interface effectively. Into these PCIe slots are plugged a few things. There are 2 SATA/SAS interface cards, and those were designed, or the intention for those was to use those with the NAS, which would run on a virtual machine here. There's one four-way gigabit Ethernet card, which is for the router. I use pfSense as the router operating system. And then there's, as I was saying, there's some limitations with this. So, for example, if you populate all the slots, then you have 2 8x links and then 2 4x links, even though they're in larger physical sockets. That's limited by the number of PCI lanes from the CPU. And we can just have a quick look at the online spec sheet for this motherboard. In particular, if we check the specifications, you'll see that it's for Intel LGA 1151 systems. It's quite nice because it can fit up to 64 gigabytes of RAM, which is more than enough to run a few VMs and a few NAS systems and such. And then you see here under expansion slots, it tells you about the physical limitations, and this is because there are, I think it's 24, might be 20 PCIe express lanes coming from the CPU. I don't remember exactly how it's configured. Some of them go, I think, through a chipset. I'm not entirely sure about that, but you can look it up. The point is, for this class of hardware with this socket, there's a limit to the number of PCIe lanes, which is why they're arranged like this. So before I go on to the next one, actually, let's just briefly just say what's on here. So I tried many different configurations. I tried different hypervisor software systems. I didn't really like any of them, so I resorted to just using plain old Debian in the end. So that's my hypervisor host is a Debian 10 operating system. Then there's pfSense, which runs in a VM, and the 4x GBE card is passed through to that. So that handles all the routing of all the different networks that I have here. The operating system for that is stored on a virtual hard disk. I don't really like to use virtual hard disks. By that I mean QCOW systems, or I forget what the other one is, but the QCOW is the one that is the default on my system, and I just use that. I don't like using that so much, especially not for things where the data is important, like on a NAS system, because there's an extra step in recovering the data in such a case, and that is something I prefer to avoid. I would rather deal with the raw disks themselves, which is why I have two HBA cards, and those are passed through to the NAS system, or at least that was the intention. It doesn't actually work that way. It didn't plan out exactly how I expected. So there is the host system, there is one VM for the router, there's one VM for the NAS system, and then I had intended to add other VMs for other things, and I do, but all of the storage for those is on the SSDs that are connected directly into this motherboard or via one of these cards, but they're not passed through. So the problems that I had with this system, or the problems that I have now, are that it's quite complex, and the pfSense router can break. There can be a network or routing problem. Often that's caused by another machine. If I'm doing an experiment with some networking upstairs, I can often accidentally misconfigure something and it can take down the network. You get a routing loop or something of that nature, and it takes down the pfSense router and it no longer functions properly. And the problem with that is it breaks everything else, because the pfSense router is run in a VM. If that stops functioning correctly, a lot of other things on the network more generally stop working, including sometimes the connection to the VM host itself. And the way that works is that obtains its IP address from the pfSense router, and it's on the .1 network. So if anything stops traffic being routed to the .1 network, which can happen sometimes, the whole thing essentially breaks. In addition to that, if the VM host itself has a problem, then that can take everything else down. It can take the VMs down, it can take the interface to itself down, and obviously that breaks everything. And because these two issues are linked, because they're essentially the same piece of physical hardware, if there's a problem with one, it generally breaks the other as well, which is a real pain to fix, and usually requires me to go downstairs, take a keyboard and a mouse down, and a monitor, plug everything in, try and get the monitor working, which if I've left something logged in via a remote desktop application, then that ends up breaking as well. So there's a lot of additional complexity there that I would rather get rid of. The pass-through then with the IOMMU groups, 3 of the PCIe slots are all in the same group. Now what that means is you may have plugged in 4 separate PCIe cards into these slots on the motherboard here, but if you try to pass through either this one, or this one, you have to pass through all of them, which means that they're no longer accessible to the hypervisor. And then I think from memory this one is separate, but because that's only a 4x link, that's actually not especially useful. The way I've got around that is to not pass through any of these, and to pass through the network card on this slot here. So that's the first issue. The second issue I found, and I'm not sure if this is me who's made the mistake, it could be me misunderstanding something, but I found that the whole IOMMU group itself has to be passed through to a single VM. That might have been me misconfiguring something, because I've seen information online that conflicts with that. So this means, the result of this is that the storage operating systems, so any NAS systems that I have, and bearing in mind that I'm trying to try more than one to find out which one suits my needs best, this means that they cannot have native access to the drives. And as I mentioned before, that makes restoring data, if there's a data crash or a hard disk crash or SSD fails, that's just an additional step that I would rather not deal with. I'd rather deal with something very simple like RAID 1 arrays, where if one SSD goes down, essentially no recovery operation is required. The data's there on a separate disk. This is a complex system in general. It's difficult to remember where everything goes, how all the networks work, because there's a physical box with 4 or 5 different Ethernet wires plugged in. It's difficult to remember what all of them do, and and what the purpose of each one is and where it gets its IP address from, etc., etc. So what I found was that I couldn't pass through more than just the network card or the HBAs. So I had to have either all the HBAs pass through and the network card, or just the network card. I couldn't pass through just one HBA, which was my main issue. And then I couldn't split the HBAs so that they went to different NAS storage OSs. But anyway, that could be me misconfiguring things. What I do know for sure, by the way, is that if you pass through a PCI-e network card, you cannot split. If it's a 4-port network card like the one that I have here, you cannot split the ports. So the whole card has to be passed through. And that makes the network configuration for the VMs somewhat limited anyway, which is another issue. It's a lesser issue, but it's still an issue. So the network looks like this. I've sort of described it already. It's a bit weird because the WAN interface comes in here, goes into this 4 GBE network card. What the IP address on that side for the card is .0.199. Doesn't matter that much. And then there's another 2 networks, the .1 network and the .2 network. And then I intended to add another network here, the .3 network, for publicly accessible, genuinely publicly accessible services. So I've already used my four slots. And I had another card, another 4-port card that I intended to pass through. But unfortunately, I can't do that because I've only got 4 slots in my motherboard. So if I use 2 slots for these cards, then I have to pass through all 3 slots, which means I only have space for 1 HBA adapter, and that then means I'm out of slots, and I can't connect all of the RAID SSDs I would like to. So that's a bit of a flaw. And it also means that if I pass through only one HBA card for the storage, then that can only be used by either the host VM, the VM hypervisor, or one single virtual machine. So again, it's quite limiting. Then there's some other stuff here on these networks, and then this is the internal quote-unquote public network where all the services like the printers are, etc., etc. And I've written ENO2 here because that's one of the ports on that Asus motherboard, and then the VMs are hosted on this system, and one of those VMs is the pfSense box, which feeds IP addresses via DHCP to any device on either this or this network effectively, and the pfSense system owns this 4-port card effectively because it's passed through to that system. So like I say, it generally works okay until there's a network misconfiguration, and then everything breaks. And the intended advantage of this was low power consumption because everything's contained on one system with a 25 watt CPU, so it's supposed to be energy efficient, but unfortunately it just doesn't work very well. So to summarize then, the PCI pass-through is by group. It wasn't obvious to me how the groups would be structured before I bought this hardware, and I think unless you're familiar with the hardware to a fairly extensive detail, it won't be obvious to you how these groups are organized. It varies by system, by vendor. It can vary even within the same series of motherboards, I believe. And what I found was that a whole group has to be passed through to a single VM at once. That could be me misconfiguring something though, so if you know different, please let me know in the comments. I don't know any way to split one of these single groups amongst multiple VMs. That's certainly true in the case of a network card. All ports on the same network card have to be assigned to a single VM, which was very limiting for me in terms of what I could do with my network segmentation, because I would have liked to have 2 cards. So effectively, my network options were limited by the number of PCIe network cards that I could have, and I don't have enough slots in the board to add more. There's also some talk online, I've heard about this, about a kernel patch that can be used as a workaround to separate IOMMU groups. But from my research, I'm aware that may have security implications. So it wasn't really an issue. It wasn't an avenue I really wanted to explore in much greater detail, just because it would have taken me too long really to investigate this, and I risk messing up my system, bearing in mind that I only really managed to get it set up stably just after playing around for a few days, and I didn't really want to mess around with it too much more. So the options for me were to pass through either one PCIe card or all of them, which would use all 4 of my slots. And the easy solution to this is just to split the router and the storage functions, and that requires building a new separate system. There's one possible alternative as well, and that is to use, as I currently use, one of the native SATA ports to host the hypervisor OS, then use another 2 or the remaining 5 SATA ports for some kind of storage array. RAID 1 is obviously the most obvious, most easy one, which uses a pair of ports at a time, and then use those arrays to host the operating systems for the VMs, because if those disks die, it doesn't matter too much, because if I find that I can't recover those OS systems from a QCal virtual hard disk file, it doesn't matter too much, because at least it's not my data that I'm trying to preserve or store on the NAS effectively. There are 3 free native SATA ports if I do this. That's not currently how it's set up at the moment, because it uses an additional 2 drives I don't currently have. So then what you may do would be to pass through all the PCIe slots. Then you don't have any issues with splitting the IOMMU groups. You just pass through everything, which would mean all 4 ports on a network card to the pfSense system, and the 3 remaining slots could be used for HBAs, which would mean you could have a maximum of 3 different independent VMs which used disks that were connected to those HBAs. If you need more VMs, then your storage has to be on those disks connected natively via the SATA ports, and that's the only way that you can configure this, at least as far as I'm aware. And I'm still not 100% sure this would work, as I've not tested it. So that's the end of my diagrams, my slides, my scribblings on paper. And the main thing that I wanted to just make you aware of was to just take away the fact that just because you have a motherboard with 4 of these PCIe slots doesn't mean it will be easy or possible for you to pass through each one independently. So although this was quite a good idea in theory, and I had enough HBAs and enough network cards, and I could plug in 2 HBAs and 2 network cards, it wasn't possible to pass those through to the VMs unless I passed through the whole lot, which is not what I wanted to do, because it would limit me in terms of the number of VMs that I could run. I wouldn't be able to test out different NAS operating systems effectively, different NAS systems. So that's it really. That concludes this. A bit of a different video today. Thought it might be useful information for a few people out there. Sorry, it's probably not the most exciting topic, but I just thought I'd make you aware if you're looking to do virtualization and IOMMU, your mileage may vary essentially, and you might find that you're in a situation such as I was, where your elaborate plan to get everything on one system didn't work. And the solution for me, what I will be doing in the near future, is to just build a separate system for the NAS and then have that in a different location, and then have the router downstairs separately, which is a bit of a shame because it seems like wasted hardware really, because the system that I have is more than powerful enough to handle a few gigabit per second of network traffic, so it seems a bit wasteful. And of course, the final limitation for me, which will not apply to that many people out there, is that I have this issue where I can only store one machine in this room because there isn't enough space. So all the other machines have to be in this room. That means if I want to put a NAS here, that has to be on the .1 network. That uses up one of my links, one of my physical wires here. And if I want my other systems on the .2 network, that uses up my other link. So if I then want another network for experimental purposes or publicly accessible services, those machines cannot be in this room unless I put a new router system here, or at least configure the Debian kernel, or whichever operating system I use here, to route traffic, then I can set up a static network on the router that's down here, a static network, static definition network, static route even for the system that's up here, and then I can have my third network in this room. Otherwise it has to go somewhere else, and it can't go here because I just don't have the space.